Welcome everyone to this math session. We'll be learning about the place value system and how to convert fractions and decimals to percentages and vice versa. This is all tied to your competencies, so please stay tuned. Don't forget to like and subscribe to the Abarasu ASAP YouTube channel, as well as utilize all the resources that will be posted on the Google Classroom platform. Get to work. Place value is important because it helps you understand the meaning of a number. If people just use numbers randomly, no one would know which numbers people meant. If someone offers you $30 or $99, you would need to know that 99 is more than 30 if you wanted a greater amount of money. Hence, from the understanding of place value, you can compare numbers and determine which is greater. Our fingers are called digits, and so are all the numerals from 0 to 9. Numerals means number characters. The place value of whole numbers begins with ones, then we go to tens, then 10 sets of tens, and so on. In other words, every time we go one place farther to the left, we multiply by our base 10. Or you can simply say the place value increases by 10 the farther you go to the left. Now, you would notice that there are commas usually after sets of 3 digits, right? Well, the commas marking off sets of 3 digits, as we can see in 1000, are used to make it easier for people to read the numbers. Properly, if you spell out a number in words, you would use commas at those same spots. For example, the number 1, 2, 3, 4 with a comma after the 1 will be spelled out as 1234. To expand this number, I need to split it up into its different places. If I'm not sure of my place value, I'll count them out, starting from the right hand digit or the last digit. This number has 5 digits. From the table previously shown, I know that this means that I'm dealing with tens of thousands. The 1 comma tells me that I'm dealing with thousands. If it had 2 commas, it means I will be dealing with millions and so forth. So I've got here 3 10,000s, 2 1,000s, 0 hundreds, 6 tens, and 7 ones. Usually we ignore the zeros in expanded notation, so this gives me 30,000 plus 2,000 plus 60 plus 7. This can be written in a horizontal form as well as vertically. Now, write the standard form for the number, which in expanded notation is written as this. Here I've got 9,000s, 300s, and 2 ones. I don't have any tens in the expanded form, so I'll need to use a 0 in the tens place to keep the slot open. You can do it this way or simply add them. Either way, my standard form is 9,302. As we established earlier, the place value of whole numbers increases as you move to the left. This would also mean that they will decrease by 10 as you move to the right. For example, the number 36.7 is a decimal number. We know this because it has a dot, which we call a decimal point. The 7 after the ones place is less than 6 because of its place value. Any number after a decimal point is less than a whole. Now, let's consider the decimal number 0.6495. The number has 4 digits after the decimal point. Each digit has a different place value. The first digit after the decimal point occupies the tenths place value using the chart by its side. There are 6 tenths in the number 0.6495. The second digit tells you how many hundredths place there are in the number. The number 0.6495 has 4 hundredths. The third digit is the thousandths place. The fourth digit is in the 10,000ths place, which is 5 in this example. Therefore, there are 6 tenths, 4 hundredths, 9 thousandths, and 5 10,000ths in the number 0.6495. The place value of a number decreases as you move further to the right by 10, which means we can write them as fractions. A link will be provided that further explains how to convert decimals to fraction and vice versa. I hope with this chart you are able to identify and memorize the various place values of a decimal number. To express 47.3692 in expanded notation, I need to write out the place separately. And this will be the standard form below. It's easy, right? The expanded form is 40 plus 7 plus 0.3 plus 0.06 plus 0.009 plus 0.0002. And that's it. To express this in standard form, you can add them together to get a standard form. Ensure when adding, you position each number in the right place value to avoid errors. For example, the 6 in the first number will not be placed directly on 9 in the second number because their place values are different. After adding, the standard form then becomes 0.06902. Go ahead and pause the video to try these problems. You can also proceed now to your Google Classroom to submit this assessment. That will be all for now. Don't forget to like and subscribe to the Abarso ASAP channel. Utilize all the extra results I'll include on the links below. Thanks for watching.